consecutive days here. And the probability that it rains none of the 3 days is 0.216. The probability that it rains exactly one of 3 days is 0.432. The probability that it rains 2 of 3 days is 0.288. And the probability that it rains all 3 days in a row was 0.064. Is that a probability distribution? Looks like one. What are the conditions we have to meet to be a probability distribution? Well, these are the probabilities, though. Each probability has to be between 0 and 1. Do I have that satisfied? All of those are between 0 and 1. The only other thing that has to happen is the probabilities have to add up to 1. They do. It looks like 1, but we're not going to know until we add, and then we look at each one individually to make sure they're between 0 and 1. So we just say, yes, each probability, I'll do this, is between 0 and 1, and the sum of the probabilities does equal 1. So if it's not a probability distribution, one of these two things is not met, and you'd have to list which one is not met. So far, so good? What do we got next here? We already did that. Nope, we're not done yet. Side. I thought there was a fill in the blank one. Make it a probability distribution. What are we going to do here? What do I need to do to figure out what to put here to make this a probability distribution? Add them together? Subtract from 1. You know the 4 of these numbers have to add up to 1. If you want to grab a calculator, you can. If you want to get common denominators, you can. Doesn't matter. Let's do common denominators. I got 2 that are 16ths. What's this one in 16ths? 4 16ths. So I've got 1, 5, 8 16ths. What does the other one have to be? 1/2. Another 8 16ths. I'm going to put 1/2. So far, so good? Well, this chapter is easy. Okay, the last thing we're going to do, you need a calculator. I'll big calculator, yeah, with lift. Okay, we're going to do mean, variance, and standard deviation of a probability distribution using lists and 1-bar stats to Tomorrow we're going to have shortcut formulas. Nope. And then when it comes to a test, I don't care which one you go with. Okay, so, let's just use the data from example 4. Yeah. Any guesses on what we might have to do here with the calculator? Just from what you know already. What are we typing in? X is going to list 1. X values. Let's just write down the steps first. Go into L1. Then what? Well, I don't have frequencies. If I had frequencies, yes, that would work. But in this case, I've got probabilities. So same thing. You can put frequencies if you have them, or the probabilities into list 2. Then what do you tell the calculator in order to find the mean, the variance, and standard deviation? One bar stat. And because we use 2 lists, you have to tell it to look back at both lists. So you just say L1, comma, L2, and it will give us all kinds of data, and then we'll grab the right one. Do you remember how to get there? So I'm putting in you can type in the fraction, it automatically kicks it into the decimal. The last one 3? Once you got to quit to get out of here. Remember to quit. Did you get it, Jolie? Yeah. I figured it was. X bar, yeah. Peggy, did you quit? Quit once you get those 8 things in. Then you're going to stat. Stat. Over to calc. 1 bar stat. And you got to tell it to look at both lists. Otherwise, what does it do if you don't type anything in? Just looks at list 1. It'll average up 5, 6, 7, and 8. That's not what we want. But when with the way the programmers built it, yes. Okay, so which number on here is giving us the mean? So the mean is the X bar. Oops, that's a bad M. I'll write them down so you mean is the X bar. What'd that come up? Oh, I got it right here too. 6.56. The variance. Can I find the variance on this screen right here? No, it doesn't do variance. Can I find the standard deviation on this screen? And these are populations we're working with. If it's a sample, we have to use the formula. And I didn't give you that formula, but these are all populations here, so we don't have to worry about it. That sigma is the standard deviation, and that's 0.86. Remember, that's an indication of how spread out the numbers are. The smaller the standard deviation, the closer all my data values are. How do I get variance then? If it's not on there, you got to square the standard deviation. So you got to square that sigma yourself. And I'm not sure if they square 2 numbers or 3 numbers, so we might be a little bit off on our answers tomorrow. I could look and see. I'll just go 7-4. So I think if we stick to 2 places, I think we'll be good. Okay. That's it for the day. I can't believe there's much in there. I don't know why I spent 2 days on this. To me, I think I finished this whole thing. Actually, I think I'm going to finish the section. Yeah, there's only one thing left in here. Oh, and then I got to do formulas. I guess I won't. Okay, I'll stay with my plan. I will stick with my plan. I gotta find the homework. Yeah. Patience.
No, I'll just wait to see it online.
I think these snowbanks are going to be here when we leave. Well, some of them, you know, they'll be low, but...
Don't they have some like taken care of?
You would think so. See, 8-1.
Just look at that. You can't even see us. No, you can't. I can't do it. I'm afraid I'm gonna snap my spine and I just can't. I usually just do the fist. Are any of you guys gonna crack back?
There you go.
No answers. I don't know. It's okay. I already told you I don't want to.